Okay, everybody, here's part 2 of a video that I made, I don't know, maybe last semester at this point, but I'm getting a lot of questions about these compound interest problems over the past 2 days, so I just thought I'd make another video where I work some of the problems that people have been asking me about. All right, so let's get into it. So first problem, suppose $4,000 is deposited at 7% interest compounded semi-annually. How much will there be in 6 years? So let's remember the details of our formula for compound interest. So first I'll write down what the formula is. There it is. P is the principal that's invested. R is the interest rate. N is how many times per year we compound the interest. If that's semi-annually, that makes N be 2, it turns out. Okay? All right. So N's going to be 2 for this one. And other than that, I think the rest of the numbers are going to go in just like they are. T is 6 years. R is 0.07. P is 4,000. Now, A is the amount that $4,000 becomes if it earns 7% interest compounded twice a year for 6 years. Okay, but that's our formula for figuring that out. All right, so this time we're trying to figure out that number. So A, the final amount, all said and done, is going to be calculated this way. 4,000 is the principal. 1 plus 0.07. All right, 7%. We're compounding semi-annually, so that means N is equal to 2. And then this power is 2 times 6, right? N times T. All right, now I'll show you how I do this in my calculator. Everybody's calculator is different, so you'll have to learn how yours works. Here's the calculator that I happen to have at the moment. I could, if I wanted to, I could just type this whole thing in, but not everybody's comfortable doing that. So let's start with this part. I'll open a parentheses. 1 plus 0.07 divided by 2. Okay? See how that's going in? Just like you see it here. And then I raise to a power, and in my case, it writes the power as a superscript on my screen, and that's going to be 2 times 6, right? Okay, so I get like so. That's this number. Now, I need to take this number and I need to multiply it by 4,000. If on my calculator, and I think on most calculators, if you just hit times, it assumes you want to multiply that number that you just had, okay? So that that will make it easy for us. We'll just do 4,000. Okay, so I can do the calculations like one at a time this way, if you want to think about it like that. If you're uncomfortable typing in the whole thing, at once, then you can do it in steps, kind of like I did it. Okay, so there's my answer. So let's say A is about, because this number is going to take some rounding. In these money problems, we normally round to the nearest penny. So that's going to be 60, 44, and 27 cents. $6,044.27. That 0.274 rounds to 0.27. And then we're done with that one. Okay, there's nothing tricky about it. We just put the numbers in the formula as they are. All right, so let's look at another one. So suppose $3,000 is invested at 12% compounded quarterly. Find the interest earned in 10 years. So when I use this formula here, the same formula that I mentioned in that last problem, here's our compound interest formula. This amount that we calculate is the principal that we started with plus all the interest that we earned along the way. So that's the final value of the account. And here, it stands out to me that it's asking for just the interest, where if I use this formula, it gives me the amount I started with plus all the interest I earned along the way. So, okay, so let's keep that in mind as we do this. Otherwise, I've got my principal, I know what I invest, I've got the interest rate. Compound quarterly, that's going to be 4 times a year, and my time is for 10 years. So let's put all that in. A is equal to, so we're investing 13,000 and our rate is 12%, so 0.12. We're going to compound quarterly, so n is 4, and this power is 4 times 10, which is 40, right? Okay. So I'll go ahead, I'll do this. I'm going to just, this time I'll type it all in. Okay, here's what this looks like. 13,000, okay, and then times 1 plus 0.12 over 4, right? Okay, so far it's going in just like that. Then I press my exponent key, which is, where is it? I'll use this, oh, there it is. Is that key right there? All right. And I could type in 40 because I know 4 times 10, but if you like the calculator to do all the work for you, you could do that. Okay, so I get this. All right, so this will become about $42,406, and if I round to the penny, 49 cents. Okay, now that's the total value in the account. This number is the principal I started with plus all the interest I earned along the way, and I want just the interest. So to get just the interest, I'm going to have to take this number and subtract the principal, which is 13,000. Okay, so that, you know, I've got the number here. That shouldn't be too hard to do. Remember, in my calculator, and I think most calculators, if I just go to the next thing I want, like if I just press minus, it assumes, okay, you want this number minus, and then whatever you type in, 13,000 in my case. I'm going to subtract the amount that I started with, and that will leave me the interest that I earned, and that's what I want to know in this case. So if I subtract 13,000, that turns out to be 29,406 and 49 cents. 29,406 and 49 cents. Okay, so there we go. Just remember, we got to look for keywords in the problem. That's the one that jumped out at me. I'm aware when I use this formula that the number I get, is the principal and the interest. Okay? All right, so that's why we subtract. No big deal. We just have to subtract the principal out of it. Okay, so let's do like maybe 2 more. I need to adjust my camera a little bit. All right, I think that'll do. So let's do this one then. Okay. So $6,000 is invested at 3% compounded continuously. So this time it's that word that jumps out. This is in contrast to, let's kind of make a comparison in our mind. Compounded quarterly, that's 4 times a year. Compounded semi-annually, that's twice a year. Compounded continuously, well, that's something different, okay? So if we are doing an interest problem and we're going to compound continuously, then our formula is A. Now again, A is the amount that is the principal we started with plus all the interest earned along the way, is P times E to the RT power. And E is a special number they are just for calculating this kind of thing. If you want to know, E is about 2.718. Okay, so it's a specialized number. You'll have in your calculator, if you have a scientific calculator, somewhere on it you'll have a key to take E to a power. You'll have a key that's there just for the purpose of doing this. All right, so we're in good shape. So there's my key for this one. So okay, so we got our formula. It's a different formula than if we were compounding quarterly or monthly or something like that. Okay, all right. So well, as far as that goes, I got my formula. I know my rate. I know my amount. I know the time. So here goes. How much is there going to be? What's the total amount? Okay. If we invest 6,000, okay, and then I take that times E to the power 0.03 times 3. Remember, the power is RT. The rate is 3%, 0.03. for 3 years. Okay. All right. Now here's how this is going to look going in here. So I want 6,000. And then remember I told you I got this button right here. So here's how I do on mine. There we go. 6,000 times E. And it expects me to type the power in because that's normally how this number is used. It thinks I'm going to do a problem like this anyway. So 0.03 times 3, right? There's my power. That's what you see it to be on paper. And so I get 65, and 5 cents. So let's do like this. Dollar amount, 65.05, $6,565.05. That 0.045 round to the nearest penny is 0.05. So 6,565 and a nickel is what we're going to end up with there. Okay, but that it is a different formula, and you have to, like, the words have to jump out. They have to be cues to do a certain thing. Okay, so here that's the word that jumped out at me when I read this one. All right, so let's do one more problem that involves calculation. I need to make another adjustment here. There we go. All right. How long in years and months will it take for an investment to double 15% compounded monthly? Now, for that one, so compounded monthly, so that's going to be this formula here, and n's going to be 12, right? Monthly would be 12 times per year. But it's just that I'm trying to find the time. I want to know how long is it going to take for the investment to double. All right. So how about this? Let's write down the formula. Here's the formula that would be appropriate for this problem because it's a problem where we're compounding monthly. We would use this same formula if we're compounding daily or quarterly or anything like that. Okay. All right. So we're compounding monthly, and I want to find the time. I know how much I end up with. I end up with double what I start with. Notice how it doesn't tell me what I start with. It doesn't tell me the dollar amount. It turns out I don't really need to know that. It doesn't matter what you invest. The time to double is going to be the same no matter what. So here's how we'll do it. We'll say we're going to end up with twice what we started with. So we invest dollar amount P. We invest principal P. We end up with 2P. And I still don't know what that is, but it's okay. So I invest dollar amount P, not given in this problem. I end up with double that. My interest rate, 15%. I compound monthly, so that's going to look like so. Monthly means that N is 12, and this is 12T. Like, I don't know the time. I don't know how long. So that's what I'm after in this problem. Now, first thing I'll do to solve this, to solve for the T right there, is I'll divide both sides by this number P. I don't know what that number is, but imagine if I divided this and that by P. It would cancel from both sides. It would leave me with a 2 here. And it would leave me with this over here, right? Okay, next thing. When we are trying to solve for an exponent, we'll use logarithms to do that, okay? And the general technique will be to apply the natural logarithm on both sides. So ln right there, that stands for the natural logarithm. The reason we do that, one, is because it allows us a way to calculate the answer. My calculator has a logarithm function in it. So that's one reason we do that. The other reason that we introduced logarithm is there's this property, this rule of logarithms, that if I have the logarithm of something to a power, I have the ability to move that power out front as a multiplier. And unless I can move that from the exponent, I really don't have a way to solve for it, okay? So I do this because it gives me the freedom to move that. All right. The way that you may have seen it when you're doing the lessons is something like if you have a logarithm of any base, this is a logarithm with a base of e, but it's still a logarithm. of a number to a power, it doesn't matter how crazy or complicated that number is, then we can move that power like so. So that's what we're going to do right now. Natural log of 2. Okay, this at 12t will be moved there, and it'll be times this logarithm, 1 plus 0.15 over 12. Okay, so why does that moving it there allow us to any way to solve? Okay, well, look. So this 12 and that number, this logarithm, I know that number looks intimidating. It's just a number. These are all now multiplied together. What's the opposite of multiplying? It would be dividing. How could we cancel? Well, I could take this equation, divide both sides by 12 in order to cancel the 12. Divide both sides by natural log 1 plus 0.15 over 12. Okay? And it will cancel and solve for the t. It'll isolate the t. And that's what I wanted. That will be a solution to my problem. Like that. Okay, so like I said, cancel the 12. Okay, that's gone. Cancel that entire logarithm number, whatever that is. That leaves me the t by itself. It leaves me with my answer. So my answer is, now I'm going to write it reading left to right this time. T equals natural log 2. All right, now we get this big number. Over 12 times natural log 1 plus 0.15 over 12. Okay, so that'll be the time. That will be how long it takes. All right, let's put this in the calculator. Here's how we can do it. We can do like this. So let me give a quick analogy. What's 10 divided by 2 times 5? Shouldn't that be 1? Okay, so watch. I can take 10 and I can divide by 2, and then I can divide by 5, and I get 1. You can divide those numbers one at a time. You can take 10 divided by 2, whatever that answer is, and then divide that answer by 5. All right, in other words, you can divide one at a time. Okay, so I'm going to do this one like that. So I'm going to do it just like I did over here. So I'm going to take natural log of 2. All right, there it is. I'm going to divide by 12. Okay, I'm going to take that number and I'm going to now divide by this logarithm. So if I just hit divide and I type natural log 1 plus 0.15 over 12, all right, then that will be it. So 4.649, so t is about 4.6498, and so on. I get this big number. Okay, 4.64 what? 4.64 what? What does that number mean? How long? 4.64 years. If the answer was specified to be in years, that would be the answer. Okay? Now, this question, though, says how long in years and months. Okay. So 4.6498 years. That would be 4 entire years. And then I need to convert this decimal number, which is a portion of a year, to months. Okay? So I can do like this. I can say 4 years and take that decimal, 0.6498, so on, times 12. That will convert this decimal portion of that number to months. So this will be 4 years and this many months. All right? Let's do the math on that. Now, it would be best if we didn't round anything. Notice how I didn't write that whole decimal down, okay? But it's my calculator. So how about this? To get that decimal without rounding it, I'll take that number. Why don't I just subtract the 4? Okay, so there's just the decimal. And now I'll take that, I'll multiply by 12. And so there you go. So this turns out to be 7.79 months. 4 years and 7.79 months. Okay? Now, in this question, I'm going to check real quick. I'm looking at it. It says round up to the nearest month. All right, so my final answer will be 4 years. And it's like technically it's this 7.79 months, but it says round up to the nearest month. And we'll just have to do what the instructions say. So 7.79 months rounds up to 8 months. 4 years and 8 months. Okay. All right, and that's a little survey of the kind of problems that you see in the assignment. This video has a little bit of everything. Now, I thought that it would be good if I could explain a little bit more about how compound interest works. And a disclaimer, like, you don't have to know how compound interest works to get through the class. Like, you can just do the bare minimum if you want to and just learn how to do the problems. And I'm not really criticizing you if that's the way you want to do it. But I think, there are people that are curious the way things really work, and they might want to know more about this. And you could analyze your own mortgage if you really learned how compound interest works. You could verify your balance every month and so on if you really learned. Because with, say, a mortgage, you accumulate interest every month, but you make a payment that's more than the interest you accumulate. And so very gradually, you pay down that mortgage by overpaying the interest every month. But how about this? Let's just do like real quick story about how compound interest really works. It's based on simple interest. It's based on the fact that in its simplest form, interest is principal times rate times time. Okay? The rate will be in percent per year, and the time will be in years. Okay? But in compound interest, the interest is periodically added back to the principal. So here's the way it would really look, okay? If we were looking at it like one period at a time. All right, so let's see if you can see all this. So suppose we invest $7,000, we'll compound monthly at 5% for 3 months. Here's what that would look like. We start with $7,000. At the end of the first month, well, we had $7,000, but we're going to accumulate a month's worth of interest. But what is a month's worth of interest? Well, interest in its most basic form is principal times rate times time. So, all right, I've got 7,000 times 5% per year times, what's the time? Principal times rate times time. The time's a month. 1 month went by. We're compounding monthly. At the end of every month, we're going to add the interest back in. So principal times rate times time, that time has to be in years, and a month is 1/12 of a year, okay? All right, so there's our balance at the end of the first month. Then we take that balance. What do we have at the end of the second month? Well, so this is what we started with, but we accumulated another month's worth of interest. So we started with this. There's a month's worth of interest. There's our balance, our principal, times the rate times the time. Okay, now we have this. At the end of the third month, all right, we take what we started with, and it earns a month of interest. We add that interest back into it. So this is what we started with, and here's a month's worth of interest that's added back in. So we repeat that. We take our balance. We add a month worth of interest. At the end of the next month, we take the new balance, add another month's worth of interest. And we take that balance and we do that for 3 months, okay? And this is our final balance right here, $7,087.86. That's what compounding is. Now we take that for granted, but when we look at this problem and it says compound monthly, well, that means like every month something like this happened. At the end of every month, a month of interest on that balance was added back into it. Now, I thought it'd be good to just verify that I can do this 1 month at a time, but I can also use this formula, and I can get the same answer. So let's see. What was the other way to do it? Okay. Now that you see what it looks like 1 month at a time, can we get there by a formula? So our formula is the amount is the principal times 1 plus r over n to the power nt. Okay. In this case, we're investing $7,000. The rate is 5%. Oops. we're going to compound monthly. So n is 12. And then what's the time? 3 months? 3 months is 1/4 of a year. The time is in years in this formula. So we're going to do 0.25 years. Okay? Because, look at that, 0.25 years is the same as 3 months. But the nature of this formula is the time I put in has to be in years. All right, so let's do this, and I'm expecting to get that answer. Okay, this is just a shortcut to doing this 1 month at a time, compounding the interest every month. That's all it is. So, okay, let's see. So 7,000, now we've already learned how to do this, but I'll type it in like this. 1 plus 0.05 over 12, raise that to the power, raise that to the power 12 times 0.25. Okay, and then I'm going to press enter, and I'm expecting to get that. Okay, let's see. For dramatic effect. Oh, syntax error. That's not what I was expecting. Whoops. Okay, all right. So I get this 7086 or 708786. I got the same number. Okay. So all this is a shortcut to that. But it would be good if you knew what we mean by compounding. This is compounding. This is what we mean when we say the interest is compounded monthly. Okay? All right. The formula is just a shortcut to that. You can see that I got the same answer doing it both ways. So now you know what we mean when we say compounding the interest.